Hello, everyone. This is the second half of our presentation about descriptive statistics. I wanted to take the time to make a second video and share with you the lab assignment that's going to be due this week. So if you go on Learning Hub and you look under this week's assignment, you're going to see a couple of things. We have the Youth Risk Behavior Survey 2019 with codes. This is an updated Jamovi file where some of the data labels have been included now. You see the 2019 Youth Risk Behavior Survey questionnaire. This is going to be useful as you consider what each question means in the YRBS dataset. You can see the PowerPoint for this week. And then you see Lab 1 assignment with Jamovi Sex and Grade 22. So let's go ahead and open that. I want to show you what the assignment is for this week. So you're going to be watching part 1 and part 2 of this presentation, but there's no embedded quizzes this time. Instead, what you're going to be doing is this lab assignment. So to do it, you need to open up Jamovi, and you need to follow along with the PowerPoint that's provided. So you can follow along with this presentation as well. But you see there are 4 activities to do and a 5th extra credit opportunity. So the first one, you're going to be creating a frequency distribution. The second one, you're creating a frequency distribution. The third one, you're creating something called a crosstab table. The fourth one, you're reversing that crosstab table. And the 5th one is a crosstab of your choice. For each one of these, you need to copy and insert the output from Jamovi. So let's look at what that means. Let's go to the PowerPoint first. Let's see here. So if we open up the PowerPoint, you can see this. The first part of the assignment says create a frequency distribution for age. And then the questions on that assignment say, how is it coded? What does that tell you about the measure of central tendency? Which one should we use? What kinds of graphs can you appropriately choose from? How many 17-year-olds are there? How many 12-year-olds are there? And then what's the cumulative percent for everyone 16 or younger? So I'm going to now open up the Jamovi file. And it's right here. And we are looking at the variable age. In order to create a frequency distribution, and this is actually in the PowerPoint as well, you click on Exploration right here, and you click on Descriptives. And then you take the variable age, which I can't remember what it is. I think it's Q2, but to check, if you can't figure this out, you can click on Data, and you can look right here. This says 16-year-olds. If you don't like that it's labeled Q1, if you double click it, you could actually edit this, and I'm going to write in the word age. That might make it a little more helpful to you. It'll definitely make it helpful to me. And then Q2 is gender. I'm just going to add a few labels here that I know we're going to need. So back to the assignment. You go to Analysis, Exploration, Descriptives, and you move the age variable. You just drag it and drop it into the variables box. What you're going to do next is you're going to click on the frequency table. And you're going to click on Statistics, and you are going to click on Mode here, because in the previous presentation, as you heard, if you have a variable that is ordinal, which is ordered categories, you need to report the mode as the measure of central tendency. So let's see what we have here. We have 2 descriptive boxes. The first thing you're going to do is you're going to right-click on this, and you're going to copy it. And then you're going to go over to your lab assignment, and you're going to paste the first table here. And then you're going to go back and get the second table, right click on it, copy it, and paste it right below the previous table. The cool thing about Jamovi is that these tables are formatted in APA format for the most part. They're really useful if you were going to publish with them. But also what this does for us is it gives us all of our information so that then we can go and answer these questions. But The first question says, how is this variable coded? What this means is these categories right here, the program uses a code to identify these categories. I'm going to go back to Jamovi. And if I look at data, you can see this variable right here, Q1 age. That's when we're talking about it. If you click that, open it up, you can see 12 years old or younger, but right next to it, there's a number 1. You can see 13 years old is a 2, 14 is a 3, 15 is a 4, 16 is a 5, 17 is a 6, 18 is a 7, right? So when I ask, how is this coded? What I'm getting at is, what does a number 1 represent when we're talking about age? It doesn't represent 1 year old. It represents the category 12 or younger. So I ask you, how is it coded? What I want you to do is literally go in here and answer that by saying 1 equals 12 years old or younger. 2 equals 13. 3 equals 14. 4 equals 15. 5 equals 16. 7 equals 17. And 8 equals 18 years old or older. Now, as the researcher, I could have used any number to represent these. I actually could have used 12 equals 12 years or younger, but notice it's a big category. It equals more than just 12-year-olds, right? So a 12 wouldn't mean only 12-year-olds were included in there. It would mean 12 and younger. I could make 13 equal 13 and 14 equal 14. That's actually my preference when I'm using age. But a lot of statisticians will do something like this. They'll start with a 0 or they'll start with a 1. This is really important because if you want to understand what your measures of central tendency mean, you need to know how these values are coded. So the variable is age. The values of the attributes are 12 years old or younger, 13, 14, 15, 16, 17, and 18 and older. So this says, which measure of central tendency is appropriate and what is the value of that category? Okay. In the previous presentation, we talked about mean, median, and mode. We said the mean is useful when you have true numbers, where a 12 equals 12, a 13 equals 13, and 14 equals 14. In this case, we have almost that, but we have these lumps at the beginning and at the end where 12 years old or younger encompasses way more than just 12-year-olds, and 18 and older encompasses more than 18-year-olds. So this is not a true numerical variable. This is not interval. That's the word I'm looking for. This is ordered categories. So this is an ordinal variable. So if it's an ordinal variable from the previous presentation, you learned that you want to use the mode as the measure of central tendency. You also learned that mode is the category that is chosen most often. So we need to go up and look. Here it says mode is 5. If we look down here, we know that 5 equals 16. If we just look really quickly, we can see in our list that the number of responses to each category, the highest one is 16-year-olds. So the question was, what is the measure of central tendency and what is the value? So the measure of central tendency is mode. The value, or the category, it's 16 years old. Okay, the second one is, how many 17-year-olds are there? If you go up here and look, you can see there are 3,102 17-year-olds. Right? And I'm not going to answer the rest of these questions for you, except I'm going to point out what some of these, the information on the table means. So here you have N and then 13,605. That's the number of people that answered the question about age. 72 people were missing. The mean, this is where I'm telling you, you got to be really careful. You have to know what kind of variable you have. If you had an interval variable where the numbers are truly the numbers, they equal what they mean, like 13 is 13, it's not a 2, then you can interpret the mean. But in this case, a 4 does not represent a 4-year-old. So average age is not 4. A 4 represents, let's see, 1, 2, 3, it represents 15-year-olds. So you never interpret the mean in this situation. Instead, you interpret the mode, which is a 5, and 5 represents 1, 2, 3, 4, 5. It represents 16-year-olds. Now, the median is the number you use if your interval variable is skewed and there are outliers. We're not going to use that because we don't have an interval variable. The standard deviation is not useful when we're using a categorical or ordinal variable, as you saw in the previous presentation. The minimum score is a 1 and the maximum is a 7, but 1 equals 12 or younger and 7 equals, it equals 18 or older. Now, I'm going to skip number 3, and you can do number 3 on your own. You're going to copy in the tables, and you're going to answer the questions. The last part of number 3, though, has you rewrite the data in your own words. So what you're going to do is you're literally going to take these 2 sentences, and you're going to adapt it to the variable you're looking at. So instead of saying, you're looking at height in meters here. Instead of saying scores on the self-esteem measure range from 0 to 1, you'll say height in meters ranges from this number to this number. Most people in the data set were X meters tall. And then in parentheses, you have the mean, and you can see that in the chart, and then the standard deviation, and you can see that in the chart. I want you to follow this format exactly. You see the M is italicized and the SD is italicized. That is the rules for APA for identifying a statistic. So I want this exactly. I want you to italicize those 2 things, because what I'm doing is I'm preparing you to write the results section of your paper. So you're going to rewrite this sentence, but with your information, or these 2 sentences. So I want to show you how to do number 4, though. Number 4 is creating a crosstab. We're going to do one with sex and grade. So let's go back to, actually, let me go back to the PowerPoint, and let's just make sure that we are on the same page with the PowerPoint. So we just did the frequency distribution for age. And now we are going to look at measures of dispersion. Measures of dispersion are basically telling us how spread out the measure of central tendency is. They're useful for comparing data. They're really common statistics, but they're not always understood well. One measure of central tendency is range, and we use that for ordinal or interval data. It's the lowest possible score to the highest possible score. We saw the range in our variable of age was 12 years old or younger to 18 years or older, or you could use the 1 to 7, because those are the values that they use to substitute for the actual age. And then the standard deviation is a measure of how spread out the responses are from the mean. I'm going to show you that now in this next picture. You remember looking at a normal curve, probably from statistics class, where right in the middle you have the average, or you have the 0 here. And about 68% of your sample should fall within 1 plus or minus 1 standard deviation of the mean. When you see a value that's a standard deviation, so like, let's say our standard deviation is a 2 or 2.5, 2.5, right? You would take your mean score. Let's say our age is 16. And if you wanted to go 1 standard deviation below 16, you'd subtract the standard deviation of 2.5. So it'd be 13.5, or you would add the standard deviation to go 1 standard deviation above the mean. So you'd add 2.5. And that tells you that 68% of the sample falls between 13 and a half years old and 19 and a half years old. That's how you use the standard deviation. And then the other thing we look at sometimes is the distribution. We talk about a normal curve, but I've mentioned a few times here, there's also the idea of skewness. When you have an outlier, let's talk about the variable income. I told you in the previous video that if we were all taking this research class and we had one person that was this wealthy business owner and she decided to take our class, she would really skew our variable, right? It would pull it really far to the left. And if we took the average income, it would look like all of us made quite a bit more money than we actually make. So to combat that skewness, you take the median, which is the absolute middle number, or the average of two middle numbers. And that gives you a better indication of what most people in your study actually are earning. So then the next part of your assignment was to find height in meters, and I've told you how to do that. The next part is to create a crosstab. So here's the directions for creating the crosstab, but we're going to do it together. You can see I've got pictures for you here for where to put your different variables. And I've got some information about how you interpret the output, but let's look at it together. So I'm going to share the Jamovi table again, if I can find it here. Right here. Let's make sure you can see it. Okay, so we are going to do a crosstab with, it was lab 1 assignment is sex and grade. Okay, so let's go ahead and do that. So to do the crosstab assignment, you're going to go to analysis. And this time in analysis, you're going to click on not exploration, but frequencies. So you click on frequencies and independent samples t-test. What you're going to do is you're going to move sex. I should rename this as sex instead of gender, just to be consistent with how it's labeled in Jamovi. Let's see here. Q2 is sex. Okay. Let's do it again. So analysis, frequencies, independent samples. I'm putting sex in rows. And the next one was, let's see what the variable was. And grade. Okay, grade is Q3, I believe. So let's pull that in there. We could label that. Yes, Q3 is grade. Okay, so you have sex in rows and you have grade in columns. What you get here is a contingency table. It's called a crosstabs table. And the way we're looking at it right now is that all of the females are sort of separated into this top row. And it says there's 6,866 females. And then the males are in this bottom row, 6,613 males for a total of 13,479. Now, if you want to know how many females and males are in 9th grade, you would look at this column right here. Total, there's 3,618. And there's 1,902 that are female and 1,716 that are male. This is not something we're going to interpret right now. We'll talk about that next semester. Okay, that's useful, but we need a little bit more information. We're going to want to get the percentages of people in each of these different categories. To do that, you click on cells, and then you can click on percent in row. And if you want to talk about females, if someone's asking you like how many females are in 11th grade, you would click on row because you're trying to interpret the row for females. But if you wanted to interpret a question about grade, you would turn row off and click on column. So let's say I want to know about 9th graders. I'm going to turn on the column and I'm going to interpret this way. I want you to notice that 52.6% when I click on row, it changes to 27.7% because it's interpreting it a different direction. You can have it all on. It gets a little confusing to interpret it this way. So I like to click back and forth. So first of all, I'm going to copy the contingency table by right-clicking and copying. And I'm going to put it in my lab 1 assignment right under question 4. And then I'm going to do the same thing for the percentages in columns, but I'm going to turn off rows now. Okay, just a moment. Copy and paste it right in there. So now here are our questions about question number 4. It says, how many girls are in 9th grade? It's talking about girls. Okay, it's focusing on girls, right? That's the focus. How many girls are in 9th grade? So if you just move this direction, you can see females in 9th grade, 1,902, and that would be the answer. 1,902. Then it says, how many boys are in 9th grade? 1,716. 1,716. But here's the tricky part. It says, of the 12th graders. That should tell you I'm looking at a column because 12th graders are a column. Okay. Of the 12th graders, what percent were female? So of only 12th graders, that's what this does. 21% are female. Okay. And then it says of males. So that means, oh, you know what? I'm doing this wrong. Oh, so glad I caught this. Of the 12th graders. So this says it's giving us the percent within the row. So you can only interpret it this direction. So if we're talking about 12th graders, we have to go down to the one that says percent within column. So here we go. Of 12th graders, 50.9% were female. So 50.9%. And then we have of males, and that is the one you interpret within rows. Of males, what percent were in 11th grade? 25%. Okay. 25%. Okay. So that gets you through that. Now, the last part of this question is to reverse the order of the variables with sex in columns and grades in rows. You go back to Jamovi. Literally all I want you to do is move sex down here and move grade up here. And you're going to get this table differently. It's the same information. If you click back and forth between the rows and the columns, the percentages change, but it's different. So I would just like for you to copy this. Whether you get the row percent or the column percent doesn't really matter, but copy the table in general, paste it in your document, and then just respond to the question. It says, do this, and then what are the differences that you note? What do you see that's different? Just give me some commentary on it, maybe a sentence or two. And for extra credit, I'd like for you to try to do this on your own. You can choose any 2 variables you'd like. If you want to know what the different variables mean, I'll show you that in just a second. But then I want you to describe your output in about 4 sentences. Okay. If I look at Jamovi and I go back to the data, you notice there's Q3, Q4, Q6. They're not, the questions, the answers are here, but the label for the question is not here. If you want the label for the question, you need to go to Learning Hub, and it says the 2019 Youth Risk Behavior Survey. If I open that, I'm going to be able to get the questions that correspond to those numbers. So if we're looking at Q9 is, during the past 30 days, how many times did you ride in a car or a vehicle driven by someone who had been drinking alcohol? So riding with someone drinking alcohol, you could actually copy this if you wanted to. I'm going to copy it myself. Control C. And then I'm going to go back to Jamovi and I'm going to paste that right in the description because it's helpful, right? And you could even write a little note here too. So Q9 is about riding in a vehicle with someone who's drinking alcohol. That's how you find out what these different question numbers mean. So I hope that was really helpful. Again, what you're doing is you are using Jamovi. You're using this data file to address Lab 1. You're copying and pasting your output into the file and then answering the questions. Once you've done that, you're going to upload your results to Learning Hub under today's class, and the assignment is simply titled Lab 1 Assignment. Okay. So if you need any help, just send me an email, but please spend some time with this video. You can pause it, rewind it, Fast forward it, whatever you need to do. But I hope this is a good introduction to measures of central tendency, a reminder about measures of dispersion, and how to use Jamovi to analyze your data. Have a good night.